Welcome to the class on ILD for simply supported bending moment, means maximum bending moment at a section when you have train of point loads on a simply supported girder. So you see the question here. A train of 4 concentrated loads like 40 kilonewton, 50 kilonewton, 60 kilonewton and 30 kilonewton. They are separated by 1.5 meters. They are crossing a girder of 18 meters. The span of the girder is 18 meters with 30 kilonewton load leading. So our task is to find maximum bending moment at 6 meters from left support. So I have marked here the point C where it is at 6 meters. Okay. So this is our job now to find maximum bending moment at 6 meters. Let us see how do we proceed. Okay, so first of all, you try plot the ILD for bending moment at 6 meters as we have learnt from the previous lectures. So where the maximum bending moment ordinate of ILD occurs under the section C. So from where it goes down to 0. So this is ILD for bending moment at C. Okay. So let this ordinate be YC, right? Now to get maximum bending moment at C, as these 4 loads travel from left to right. So how do I place these loads, or for what position of these loads do I get maximum bending moment at C? Okay. So you might have read a condition or known a condition that when you have multiple point loads, you shall check a condition that the average load on left span is equal to average load on the right span. The left span means to the left of section, right span means to the right of section. So that means I'll write it in a short form. Average load on AC shall be equal to average load on BC. So this is the condition that you shall check for. Okay, so let us go by trial and error. So in case of say trial 1, as the loads move from left to right, let the 30 kilonewton load cross this section. So 30 kilonewton load cross section C. So what are the loads to the right of section? So only 30 kilonewton. To the left of section, you have remaining loads like 60 kilonewton, 50 and 40 are still to the left of C. Okay, so now find this condition, that is average load. Average load, I call it say W average left side is equal to, so what you have, 40, 50, 60 by 6 meters. This is average load on left span. So this works out to be 25. Okay, whereas average on right hand side, it is to the right of section C, there is only 30 kilonewton load and the span is 12 meters. The right hand side span is 12 meters. So this works out to be 2.5. So the condition that we have here is average load on left span is greater than average load on right span. Right, we'll go for trial 2 where the next load crossing the section. See, 30 crossed the section. Now the second load, that is 60, crossed the section C. So what you have on left span, average load on left span. So remaining two loads, that is 40 and 50, are to the left of C. So we'll have only 40 and 50 to the left. So the average works out to be 15. Now the right hand side, you have 30 and 60, these loads. So this works out to be 7.5. So the condition is still the average load on left span is still greater than average load on right span. Okay, let us proceed further. So we'll have trial 3. Okay, so now for trial 3, let 50 kilonewton is also crossing the section, cross C. So the average load on left span. So now you have only 40 kilonewton on left span. Remaining 3 loads cross the section. So it is only 40 on left span. So this works out to be 6.67. Now on to the right hand side, average load. You have other 3 loads like 50 plus 60 plus 30. All 3 loads now on the right span. So this works out to be 11.67. Now the condition has changed. The left span average load is now less than average load on right span. So the exactly equal to condition will not arrive here. So wherever there is a change of condition, that particular load, that you have to make a note, and that load shall occupy exactly the place over the section. So now after these trials, we have decided that 50 kilonewton shall be on C. The rest of the loads take their places. So now let us place the loads after you decide the places. Okay. Right. So now you have 50 kilonewton load onto the section. Okay. Rest of the loads take their places. Like at 1.5 meters distance, you have 40 kilonewton. Okay. And to the right of the section, you have 60 kilonewton load, and at 1.5 meter after that is 30 kilonewton. So these are the locations which we decided that this position will give us the maximum bending moment at C. So drop all these points onto the ILD drawn. This is what you have drawn, ILD for bending moment, which you have learned in the earlier sessions. So let us drop all these points onto ILD. So we need all these ordinates of ILD to find the maximum bending moment at C. So let us call this as YD, this is YE, this is YF. Okay. So now let us find the ordinates. So let us first find YC, which is exactly at the section. So to the left it is 6 meters, to the right it is 12 meters, total it is 18. So this works out to be 4. Then once you get YC from similar triangles, you get YD, okay, which is 4.5 divided by 6 into 4, which will be equal to 3. So how you are able to write YD value? You see, this is 6 meters, and from here to here it is 4.5 meters, because this is 1.5 meters. So from these two similar triangles, you will write a relation YC by 6 is equal to YD by 4.5. So that will give you YD value. Similarly for all other cases, like to the right of section, this is 12 meters, and from here if you see 12 minus 1.5. So likewise 12 minus 3 for YF value to get. Okay. So likewise we will write all these values. So I need YE value. So where it is 10.5, that is 12 minus 1.5 divided by 12 into 4. This works out to be 3.5. Similarly YF, it will be 12 minus 3 is 9 by 12 into 4, which works out to 3. So now we are ready with all the ordinates. Now to get maximum bending moment at C is equal to the load multiplied by corresponding ordinate. 40 under 40 kilonewton you have YD ordinate, plus under 50 kilonewton you have YC, under 60 you have YE, under 30 you have YF. Just multiply with the load and ordinate. Okay, so it is 40 multiplied by YD is 3, plus 50 multiplied by 4, 60 multiplied by 3.5, 30 multiplied by 3. So this whole thing works out to 620 kilonewton per meter. So this is the maximum possible bending moment which can occur at C, location C, when these loads travel from left to right. Okay, thank you.